Hello, everyone. Welcome back to this bioflow short tutorials, where informally I show you how to use different analytical modules. In the past videos, I show you how to retrieve your phenotypic, genotypic, pedigree, weather, and QTL information using the data management retrieve new data section. I also have shown you how to save your analysis as you move through the pipeline and also how to retrieve it when you're back. And we already started showing you some of the selection modules, particularly on the genetic evaluation for quality assurance and single trial analysis. The focus of this video is going to be on multi-trial analysis, where we can combine multiple sources of information like phenotypic, genotypic, weather, and pedigree information. So I'm going to start loading or retrieving an old file that we called STA last time. So I'm going to upload it, and I'm going to load the object. You can see that I receive a success message, so it's good to go. And I will go to the selection menu under genetic evaluation and select the multi-trial analysis module. You can see that I receive a status message saying that my data is complete and I can proceed to perform the MTA. And that's because I already performed the STA, so I have enough information to do it. So you can see that, as always, there is 3 tabs at the top. The information tab that tells me the status of the data set, the details of the module, some references on the methods behind, and the software used to fit the models in the background. Then you can also see the input tab at the top, where we specify the input parameters for the modeling. As I mentioned in the past, the gray boxes are used to specify your parameters, and everything below the gray box is just visualizations to help you pick the right input parameters. In this case, you can see that the plot that is trying to help me to pick the right input parameter for the timestamp is just a network plot that is telling me that I already did a QA for phenotypes, and then that was used to perform an STA, and then this can be my input timestamp to do the analysis. So I will pick that one. You can see that it coincides with the blue label. So I pick that one, and then I can move to the next input parameter, which is picking the traits. In order to decide which traits I should analyze, you can see that I'm getting 2 possible options. And before I pick them up, you can look at some of the results from the single trial analysis to understand if some of these traits have good heritability or reliability and should be fitted or not. You can see that both traits have good locations, but they also have some bad location. But that at least is not telling me that I should remove one of the traits. So I will go ahead and pick both traits since I have good information for both. Even though I can see that 2021 NYS1, it doesn't have genetic signal. I can also see, the distribution of the values for the different environments, for the different traits, for example, grain moisture and things like that. And then I can go ahead and move to pick the model that I want to fit for these traits. You can see that the default model is to fit the environment as the fixed effect and the designation or germplasm as random effect. The genetic evaluation model is the blob, but I can also select pedigree blob if I have pedigree, genomic blob if I have markers, single step G blob if I have, or single step blob if I have pedigree and markers, and also the RR blob if I have markers. So I will first start with the blob, and then I will show you something more sophisticated. And you can see that the visualizations that I get to see what is the model that I should fit is telling me first if I have what information has phenotypes, but also has genotypes and pedigree and QTL, etc. You can see that there is 782 entries that have phenotype, and from those, only 780 have genotype. So I can fit a G-blob model or an RR blob model without any problem. And also I can fit a pedigree model if I have the pedigree, selected. And then just for the information, I also have most of this material with QTL information. So like I said, for now, to don't first show something simple, I will just fit the blob model, which doesn't use pedigree markers or anything else. And then I can move to the tab to specify the G by E modeling. The G by E modeling is asking me which traits should be fitted to interact with the genotype effect, or in this case, designation. And currently, I only have the option of environmental index because this module fits the Finlay-Wilkinson regression. But if you extracted under data management weather information, you can also add the environmental variables like temperature, precipitation, etc. So the Finlay-Wilkinson regression will be, fitting the genotypes regressed over those environmental variables. It's also asking you how many environments should exist for the Finlay-Wilkinson to operate. And the default is at least 6. So right now, because we only have few environments, this would not fit the environmental index. So if you really want that to fit that one, you can reduce it. Even though, it's not really recommended that if you have very few environments, you fit the Finlay-Wilkinson regression. But at least for this particular data set, let's remember that we have, for example, for yield, let me put some correlation labels and names. We only have 1, 2, 3, 4, 5 environments. So I will put, let's say, 4 as the threshold. I can also see the sparsity of the analysis. I can also look at the connectivity between the different environments. You can see that in the different environments, I have different number of entries and the different levels of connectivity that exist between them. So to be honest, in this particular analysis, if I were not using marker or pedigree information, probably would not be a good idea to feed all these 5 together. I would only feed in this cluster of 3 environments that have good connectivity, possibly maybe also this last environment, but definitely not this NYS1 that, by the way, is the environment with very low reliability. But just for the sake of showing the how to fit the model, like I said, these visualizations are exactly for this purpose, to allow you to think twice what should be fitted or not. So I'm going to go to run analysis and click on run MTA. And before I click on that, you will notice that there is some additional or optional options to exclude specific fields for specific traits. For example, I could exclude that field by in both traits by changing this number 1 and changing it to 0 by just double clicking. This is not necessary right now because actually there is a threshold for the for the traits. You probably we didn't discuss it, but here in picking the model, there was some additional model settings, and there is a threshold for lower bound in heritability and reliability, which is set to 0.2, meaning that everything that is below 0.2 will be excluded. So I don't have to do exclude location by location. But I just want to show you that that is possible as well if you want to specifically don't include certain environments. Once you're done with that, then you can click on Run MTA. And then it will fit a multi-environmental model for both traits. You can see that I get a list of predictions where I get the predicted value, the standard error, and the reliability for each entry for the across environment estimate. I also get some metrics like mean of the trait, coefficient of variation, reliability, genetic variance, and residual variance for 2 traits, some modeling parameters, and then also a dashboard report like in the previous modules where you can also download that dashboard. And there is some nice visualizations that you can look at. For example, here you can see that for yield, there was 3 environments being used at the end after the, putting the filters on heritability, reliability, and excluding. From the 5, only 3 were used. The connectivity between those environments that were used for the analysis, and also the genetic correlation between these environments. Also, a biplot is shown there. Some across environment metrics can be visualized. You can see very low reliabilities for these two traits, the variance component ratios, and the across environment estimates for the different entries for the different traits that you can select using the drop-down menu. You can see that there is a significant amount of materials. So this plot takes some time to be built, but you can see by putting or scrolling over the name of the material under designation. This one, for example, is W10004 underscore 0014/PHC51. And I can see what is the predicted value and the standard error for this particular entry. Okay, and you can always download that report by clicking on Download Dashboard. You could do the same as before to fit the GBlob model. It would be kind of the same. You can see that I'm repeating the exact same thing. And then you can see that the GBlob model finally finished. Is building the dashboard, so don't get scared if feels that it's frozen a little bit. It's just computing the visualizations. You can see that it's very, very similar. But now you can see that this particular across environment estimates has changed because it's differentiating between the GBBs of the material that was tested, the GBBs of the material that was totally predicted, and the total genetic values or material that didn't have marker information. I don't know if you remember that there was two materials that did not have marker information. In this case, I'm just clicking on two of these entry types to remove them and see which material were these hybrids that did not have marker information. I hope this was useful. If you have any additional question, don't forget to go to the About Us section under the Home menu, Contact and Development tab, and click on Support Desk, and then you can send us a message with your questions and your suggestions as well. If you want to contribute as well, don't hesitate to go to the GitHub repository in the bioflow package and declare anything you want to be included or be considered for future versions. I hope this was clear enough, and good luck with your analysis.